with reference to bridge control of large slow propulsion engine, how starting and reversing is achieved. Investigate and proposal remedial action if the engine fails to start on air, turns on air, but fails to fire on fuel, fails to reverse. So this is a maneuvering diagram that you will have to draw for this answer to give a clear-cut idea of how the reversing is taking place. There are some points that you should know while reversing takes place. First is your puncture valve, air has to be disconnected. Second, turning gear interlock has to be disconnected. Third, your fuel pump has to be reversed. And fourth, uh, your starting air distributor has to be reversed. After this, you should be able to induct the pilot air to the starting air valve to open the starting air valve. And the main air starting valve also has to open. So all these functions will take place, then only your system will be operational. So consider in this diagram that we are starting the engine in astern direction. So start and astern I have written here. Okay, so in this condition, the control air will come from the start valve once you give the command for start. It will go from here. It will come through this line here. As you can see my pointer, it will go and operate valve number 9. Once valve number 9 operates and your turning gear interlock is disengaged, air will pass from here. It will go through this arrow. It will go and open the main starting air valve. So once the main air starting valve is open, 30 bar pressure air will come and wait near the starting air valve. Okay, so the air is waiting near the starting air valve. Now once this has happened, the second step is this air has to go somewhere. So it will go from here and it will pass through this valve and operate valve number 7. So valve number 7 is for the astern. So once this valve is operated, the air from the main airline will come from here. It will pass through this astern valve and it will go and put the plunger, your fuel pump roller in the astern direction. This same air that is coming from this line will go through another branch and it will operate the starting air distributor, the pilot valve for the starting air distributor. Once this distributor changes its position, the 30 bar air pressure will pass through this and operate on top of the starting air valve, and the air will be inducted into the engine for turning the engine in the astern direction. Once the engine is turned to the astern direction, after a certain revolutions, there will be a timer provided which will activate the basically it will activate the fuel injection. Okay, so that time the fuel pump plunger will your fuel pump will start to inject the oil and your firing will take place. So this is just a basic idea how your reversing will take place, how you have put it on astern, and how will the firing take place. So here I have written, you can see pilot valve with roller arrangement which sits on distributor cam radially when actuated ahead or astern. Okay, so some things you should note: the remote valves 1, 2, 3, 4 can be operated from ECR and bridge also. So 1, 2, 3, 4. Now in this answer, as we are saying, we have operating from the bridge. So if you're operating from the bridge, you have to mention that these are remote valves from the bridge. Okay, so you will be pressing the start and you will be pressing the astern. Okay, so these two valves will operate. This is the local valve number 5. Okay, locally also you can operate it. That time this air will come and operate here. If you are remotely operating astern, then the air will directly come from here and operate this valve, or else from the local valve the air will come and operate valve 7. Okay, so this is a basic explanation for the maneuvering diagram. For a recap again, when the start is pressed, air will come from here. It will pass from here, go and operate valve 9. Valve 10 is disengaged. So air will pass from here, go through valve 9 and open the main starting air valve. And the air will wait near the starting air. Now, if you have operated the astern valve, air will come from here and operate the remote astern valve that is provided. Okay, from here now what will happen? The control air will pass from here, go through this and put the fuel pump on the astern direction. Similarly, the same air will go and put the distributor on the astern direction. and as per which unit is supposed to fire, that particular pilot valve will operate, and it will give the air for that particular cylinder starting air. Okay, so pilot valve will come on that cylinder starting air valve, and the air will be inducted, and the engine will start to turn. Now once it is turning, there will be a timer provided for this line so that the puncture air valve will drain slowly, and once the required RPM has been achieved, by the time this puncture valve is already isolated, the air is isolated from the puncture valve, and this fuel pump will start to inject the oil. Okay, so that's how it happens. So this is about your maneuvering diagram. Now, same thing I've explained here in words. Consider that the command for starting air in astern was given with from remote location, the bridge in this case. In this case, the valves that will initially activate will be 1 and 4. Consider valve 4. When this valve is activated, it will activate the local astern valve 7. The control air will then pass through 7 and put the fuel pump roller in astern direction. At the same time, the same controller will also activate the pilot air valve 8 in astern direction. Note, the pilot valve will be put in astern direction, which puts the pilot valve roller on the astern cam of distributor. The distributor cam profile will be determine the position of the pilot valve. Now consider the valve 1. When this valve activates, the control air will pass through it and activate valve 9. Valve 9 will allow air to pass through to open the main starting air valve for turning the unit, only when the turning air interlock is disengaged. As seen in figure, it may be noted as starting command is given, there is no air to activate valve 11, and hence the air above the puncture valve will drain and allow the fuel pump to develop pressure for injection. Normally, draining of this air will take place once the main engine has attained the required starting RPM. Summing all the above points, it should be noted that the main starting air valve will open and 30 bar pressure will be standby at the unit starting air valve. The pilot valve, once activated in a stern direction, will open the unit starting air valve and turn the engine in astern. The fuel pump rollers will be pushed to the astern position, and the air to puncture valve will be released, hence allowing for firing at astern once the firing RPM has been attained. Investigate and proposal remedial action if the engine fails to turn on air. What will you do? How will you investigate, and what remedial actions if the engine fails to turn on air? So low air bottle pressure or airline valves may be shut. Air bottle isolating valve, automatic valve will be malfunctioning, so you rectify that. Control air valves faulty or less control air pressure, rectify the control regulator, basically the pressure regulator. Starting air automatic valve jammed, you have to overhaul it. Reversing not taking place completely. Okay, so this problem has to be looked into. Maybe the reversing mechanism is stuck. Controlling valve for fuel or start is not in its end position. Okay, that time also you can have uh, starting on air problem. Okay, phase to turn on air. So again, this particular linkages have to be checked. You give a kick ahead and astern maybe, and you may get a kick, or else you have to overall this linkages. Bursting disc on starting airline damage, okay, of that particular unit. When it's going to fire, that unit bursting disc have been damaged, maybe 2 or 3 must have been damaged, that's why you are not able to turn on air. Fuel lever on maneuvering stand not on remote mode. Okay, so if you have gone for emergency maneuvering, sometime tried out and you forgot to put it on the remote mode, again you can have this issue. So see that it is put on the remote mode before you can leave the emergency maneuvering stand. If spring air pressure for the exhaust valve is not sufficient, then you can have loss of compression air and your engine will not turn. Auxiliary blower not running, okay, if that also is a safeguard sometimes, that your engine will not turn. No oil pressure due to exhaust valve being open or insufficient spring air pressure. Okay, if the valve is open, same thing, compression pressure will not be built up. Starting air distributor has not activated its end stop valve. Basically, your starting air distributor has not reached to its end position. Okay, then again you will have no turning. The pilot air is not being inducted into the system to open the starting air valve. Means the spool has not come to its end position. air starting distributor piston is sticking or incorrectly adjusted, or control valve sticking. So you must have overhauled that distributor and the pilot air valves were not overhauled properly. So again, you can get sticking of that spools and air will not be inducted. Cylinder start air valves are defective or sticky. So starting air valves of each unit has to be tried out before maneuvering. 2 hours prior to departure, you have to check them, because if they are not operating well, you can have an issue on hand where you won't able to start the engine. Turns on air but fails to fire on fuel. If the puncture valve was stuck, this can be remedied, for instance, by threaded special tool to ease the puncture valve. So you can put a T-type tool with a thread, put it in the puncture valve and lift and push it 2-3 times. So ease the puncture valve. Okay. So once the puncture valve is eased, the fuel will start to be inducted into that unit. You can know that by the exhaust temperatures. It will be lower if that particular pump is not injecting. Fuel regulating linkage is jammed or held back by stop cylinders. So basically overhaul and ease them up. Governor is defective and does not release the fuel linkage, and there is no boost air to governor. Okay, so even if the governor is defective or not functioning properly, or you are not having boost air for the governor, then again you can have issues. So the governor has to be checked, okay, and rectified on priority basis. Rotary valve of the rotation direction safeguard is sticking. So basically, if this also happen, make it free and overhaul it if required. Fuel filters is blocked or fuel pump index is too low. So if the fuel filter is blocked, clean it. Fuel pump index is too low, the racks have to be adjusted, ease it up. Normally a routine should be made weekly, at least you should lubricate the racks and keep them ready. Preset control air to the governor is too low. Okay, so governor air that is going to governor, you have to check that. Okay, maybe some blockage in the line, so rectify that. Adjust the control air to required pressure. So control air in the system, if it is low, again you may not have you may have many issues. So better see that the control air that is coming from the control air dryer is of the correct pressure. If required, adjust the control the regulator that is provided for the control air. So another thing can be it fails to reverse. Starting air valve for that unit may be sticking basically, so it's not able to reverse. Okay, so again you have to overhaul the starting air valve. Then reverse control valve is jammed. Then coil of the solenoid valve for the desired direction or rotation doesn't get voltage. So the solenoid valve for the rotation, basically if it's a coil type, this is for the electronic engines. If you have solenoid valves, if they are not operating, you replace the solenoid valves. Control air signal for desired direction of rotation does not reach the engine. Okay, so if your signal, basically if it's a electronic engine, signal has to go for a rotation. If it's a pneumatic mechanical engine, conventional type engine, the air has to, you have to have air going for that pilot air valve. Okay, if the line is choked, again you can have issue. So, the reversing servo motor of the fuel or starting air distributor is jammed and gets stuck before reaching a new end position due to insufficient oil pressure. Therefore, engine turns on air but no fuel is released, as rotation direction safeguard blocks it. Okay, so then again you will have to see this issue. If the engine is running in one direction and reversed, if the engine is turning on one direction and reversed, the propeller motion continues. Okay, so sometimes due to the inertia, the propeller will keep on rotating. You have to wait for the propeller to reduce its RPM, and then only you can reverse the engine. Otherwise, it may not reverse. The propeller may tend to turn the engine in the original direction that is opposite to the given movement. Therefore, the rotational direction safeguard blocks the fuel.